Okay, I greet everyone. Welcome back. Now we are doing the sine function analysis. If this is the first video, I recommend that you are looking for the first video, which is written how to grow a trigonometric graph without using a calculator. You will see the first function that we are taking each trigonometric ratio and trigonometric function at a time. So this is a second video where we're just dealing with sine function. So after we've drawn the video, after we've drawn our graph like this one, you can see our graph here. There will be the questions about this graph. You need to understand this basic analysis of this question so that you can able to answer. One of the first thing that will be answered, you will be answered to give something that is called let us put it to this. You'll be asked to name the intercept of the graph, right? The intercept of the graphs. Y-intercept of the graph and the y-intercept as well as x-intercept of this graph. What are intercept the graphs? So the intercept of the graph are those points that are cutting through the origins of the graph here. So basically at this point and that point here and that point here are called the intercept. So know that if they are asking you the intercept, they are looking at this 1, 2, 3, 4 points here. They are the intercept. They will not always be standing here. It depends to the nature of the function. But in sine function, this graph will stand here, where sine is just a simple original function like this one. But they depend on how the function is being created. Sometimes they will stand here, you will find them being here, you will find them being any here. But it does not force them. So they will even be here. Okay. So as per this function, we can say that for n x-intercept here are as follows. The x-intercept, right? We will say that the x-intercept for x element here. Let me just say for x element, which is negative 360 degrees, which is negative 180 degrees, which is 0 degrees, which is 880 degrees, and which is 360 degrees. Go back here. Then y is equals to 0. So this is the intercept. These are the intercept. I don't want to draw them with the point, so that's why I'm using this, and that one is my y-intercept. It's like this one. Y equals to 0. For every of this point, my y is equals to 0. So for x-intercept. But what about y-intercept of this graph? Y-intercept. Y-intercept. We can see that when we're talking about y-intercept, this graph is just cut. It does not cut anywhere below 0. It does not cut anywhere here. Anyway here. But that does not mean that this graph does not have a y-intercept. But the y-intercept is just I'll just call it y-intercept. I don't know, but it's within the origin. So I will say there is no here. I'll say there is no y-intercept. Okay. Let us let us talk about the domain here. The domain. So note that if I'm talking about the domain, I'm talking about the set of all x inputs. Is a set of x inputs here. Input values. They are called the domains of. So coming back to this graph, even this graph is starting here, but the truth is that this graph is continuing. This graph will continue, is not stopping, is continuing. So you can see that this graph allow every possible values of x, even 10, even 5, 4, 3, 2, 1, negative 0, negative 0.5. So by that one, I will say that the domain is that x element allows every real numbers. Okay, but what about the domain? The domain is a set of y values. Is a set of y values here. Is a set of y values. It's called a range. Sorry, not the domain here, but the range. I'm repeating this thing. Sorry. All right. I meant to say the range. The range is a set of all possible values in the function. It's called the range. So the range. So let's come here. We can see that the graph is reaching maximum point at 1. Maximum point. The graph cannot go. It can be just between 1 and negative 1. The graph is not permitted to escape this point. So the range of this graph is that y is just the element of the square bracket 1, negative 1 maps 1 to 1, sorry, or put it on the interval form. I will say that the values for the range is the possible values of y which are between 1 and equals to 1 and greater than minus 1 or equals to minus 1. Okay, I will say like this one. So these are just the two answers we can offer as the range, right? Okay, let us take the following one. Let us take the period, something so called the period. Before I take the period, let me show you something, right? So before we have a period, we need to know this. This is a function. It says y is equals to sine x. But the original function of this graph is that y is equals to a sine x. And we will talk about these values. These values control the shape of the graph. And this one follows the period of the graph. So that's why I'm wanting to talk about these values. So the period of this graph, the period of sine actually is nothing but it is equals to 360 degrees divided by b here. So in this graph, b is just 1, so the period is 360 degrees over 1, so it's just 360 degrees. Okay, that was a period. I'm done with the period. Okay, right, so let's continue. Let's talk about the amplitude. Okay, I'm not okay. The amplitude of this graph. So amplitude is just the vertical distance between the minimum point to the maximum point. Okay, you can just say maximum to minimum point, but it's a vertical distance here. So the vertical distance, it is this line. I'm just drawing this line here. So this distance is called the amplitude here. This distance is an amplitude. Amplitude. Sorry for my spelling. Amplitude. Okay, it's called for the amplitude, right? So the amplitude is m here. Sorry, the amplitude here of this graph is to just take the maximum minus the minimum. So it's always equals to the maximum of the graph minus the minimum. So I was saying here is the distance between, but the formula is maximum minus the minimum, so it will be equals to 1 minus into minus 1, and it is equals to 2. Coming here to look that the maximum is positive 1, the minimum is negative 1. So if I plug them, I substitute them, I will get 2 and 2, voila. And these were just the short properties of the functions, and we're gonna, in this video, we're gonna be looking at the shift of the graph. We're gonna be looking at the shift of the graph, the reflection of the graph, and that is all we're gonna be looking. Thank you.